Hello everyone, welcome to Numeric Ninja. Today we are going to discuss a problem that is taken from JEE Advanced 2014 paper, which is as follows. Let A belongs to R and F run from real set to real set, and it is given by f of x is equals to x to the power 5 minus 5x plus A. Then which among the following four options are correct? Now, if you want to try this problem out, then let me tell you that this problem can have multiple correct options. So with this said, let's start solving this problem. Now, we are going to solve this problem trying to visualize this problem, trying to understand the graph of this function, rather than to approach this problem in a more rigorous way. Now, to approach this problem by graphs, we must have certain concepts. Let's first look into those concepts. Let's first draw the coordinate system. Here this is the coordinate system, this is the x-axis and this is the y-axis. And suppose that this is the graph of the function y equals to f of x, and we know that y equals to f of x looks something like this. Now I define another function g of x, which is same as f of x plus 3, and I need to draw the graph of g of x. Now let's see how we can draw the graph of g of x. If I take any point, suppose say alpha, I can find that where is this point alpha comma f of alpha in this coordinate plane. Now suppose that this point over here is alpha comma f of alpha. Then we need to find out where is the point alpha comma g of alpha. Now remember that g of x was equals to f of x plus 3, and this was for all x. So we can say that g of alpha must be equals to f of alpha plus 3. So the coordinate, which is alpha comma g of alpha, is actually alpha comma f of alpha plus 3. So we can say that if I take a coordinate which is just at a distance of 3 units from the coordinate alpha comma f of alpha, and it is actually the perpendicular to the x-axis, then it will be the point of alpha comma g of alpha, and this distance over here is actually of 3 units. And similarly we can say that if we take up any point in this graph of y equals to f of x, then we will find that just if we go in the upward direction by 3 units, we will receive the point beta comma g of beta, given that this point over here was beta comma f of beta. So we can say that the graph of g of x would look something like this, because all the points is shifted upwards by a factor of 3 or by a magnitude of 3. So we can say that the graph is just shifted upwards with this length by a magnitude of 3, because the length is 3. Now suppose if we want to draw the graph of h of x, say it's f of x minus 3, we can say that by the same logic the graph must be shifted downwards by a magnitude of 3. So this is the graph of h of x is equals to f of x minus 3. So let's see an animation to understand this concept in a more detailed way. You can see that we have first drawn the fundamental graph of y equals to x square. Then I have varying the values of c on the function y equals to x square plus c. You can see that how the graph is moving up and down as I am changing the values of c. I hope that you have understood this concept, and with this concept let's start solving our main problem. Now our function was f of x is equals to x to the power 5 minus 5x plus a. Now if you look carefully here, a is actually a constant. So if we know the graph of f of x, we should not write f of x, we should write some other function. Let's suppose g of x is equals to x to the power 5 minus 5 of x. If we can draw the function, the graph of this function, then we can draw the graph of f of x, because f of x is nothing but g of x plus a. So let's try to draw the graph of g of x, that is over here. Now we want to draw the graph of g of x is equals to x to the power 5 minus 5x. Now let's first find out what are its roots. We can say by putting it 0, it factorizes to x square minus the square root of 5 times x square plus the square root of 5 equals to 0. This further factorizes to x minus square root of, the fourth root of 5 times x plus the fourth root of 5 times x square plus the square root of 5 equals to 0. Now we want to draw the graph of g of x. Now let's again take up the coordinate axis, the x-axis and the y-axis, and now let's draw the graph. The graph of this function g of x would look something like this. It will come up from minus infinity, because the degree of this polynomial, because this is a polynomial, the degree of this polynomial is odd, so it will come up from minus infinity. Then cut the x-axis first at point minus the fourth root of 5, and then cut this point at 0 at the origin, and then again we'll cut the x-axis at the fourth root of 5. Now we can see that there are some local maxima and some local minima in these points. Let's try to find out those local maxima and minima. This is the local maxima, you can say, because it is in the upward, and the local minima is this over here, definitely. So to find the local maxima and the local minima, we first need to differentiate the function. So if we differentiate the function, that is g of x, we get it is same as 5 times x to the power 4 minus 5. And if we put this is equals to 0, we get x to the power 4 minus 1 is equals to 0. This factorizes to x minus 1 times x plus 1 times x square plus 1 equals to 0. Now for any real x, this cannot be equals to 0, so x can be equals to 1 or minus 1. Now let's find out what is g double dash of x. We can say that g double dash of x is nothing but 5 times 4 times x cube, and this is nothing but 20 x cube. So we can say that g double dash of 1 is equals to 20, and g double dash of minus 1 is actually equals to minus 20. So we can say that at x equals to 1, it will have the local minima, and at x equals to minus 1, it will have the local maxima. So this is the point of 1 comma something, but we don't know what this value is, and here it's minus 1 comma something. Now if we put g of 1, we get it's nothing but 1 minus 5, which is nothing but minus 4. So 1 comma minus 4, and if we put minus 1 in, we get it's nothing but minus 1 plus 5, and this is nothing but 4. So we have drawn the graph of g of x equals to x to the power 5 minus 5x. Now let's copy this graph and paste it down, and let's try to understand what will be the graph of x to the power 5 minus 5x plus a. Now initially our function g of x was x to the power 5 minus 5x, but our original function that was f of x was actually g of x plus a. Now there were certain options. Let's see out the options. If a is greater than 4, if a is greater than 4, then fx has 3 real roots. Let's see whether this option is correct or not. Now if a becomes greater than 4, let's see what happens when a equals to 4. If a equals to 4, then we can say that all the points are shifted upwards by a factor of 4. So we can say that this minus 4 over here will touch the origin, will touch the x-axis. So this graph will look something like this. This will look something like this, of x to the power 5 minus 5x plus 4. So when we'll take a to be more than 4, try to understand that here there are only 2 real roots, because it's cutting the x-axis 2 times. So now when we'll take a to be greater than 4, this root will not exist, and hence there will be left only 1 real root. So we can say that if a is greater than 4, then there exists only 1 real root. And if you look at the options carefully, so this option is not true. So if f of x has 1 real root, it must be root, should not be roots, if a is greater than 4. Now if a is less than minus 4, let's see what happens if a is less than minus 4. Try to understand, the same thing will happen. Let's paste the diagram once more. Yes. If a is less than minus 4, so f of x, the new f of x, is nothing but x to the power 5 minus 5x minus 4. So the graph is shifted downward. So you can say that this point over here will touch the x-axis again. So it will look again something like this. And you can see that it touches the graph only at 2 points. And if a is greater than 4, so it's strictly greater than 4. If you see the options, these are all strict inequalities. If a is strictly greater than 4, we can say there exists only 1 real root. So we can say that this option is also not correct. The only option that is left is f of x has 3 real roots if a is less than minus 4, is greater than minus 4 and less than 4. Let's see what it happens. Let's again paste the diagram over here. Yes. Now here a is in between a range. So if a is 4, we have seen the graph looks something like this, and if a is equals to minus 4, the graph looks something like this. So we can say that whenever a will be between minus 4 and 4, we can say that the graph must lie in this region over here. I think it's looking a bit. It must lie over this region, and try to visualize if this graph lies between this region, we can say that the graph must cut the x-axis at 3 points exactly. So as it is cutting 3 points, when you're going to move this graph upwards, it will look something like this. If a is positive and it is less than 4, it will look something like this. See there are 3 graphs, 3 points at which it is cutting. And also if a is negative and if the graph is shifted downwards and a is greater than minus 4, then also you can see that it's cutting the x-axis at 3 points. So with the help of visualization, we have seen that the graph cuts the x-axis at 3 points. So hence the f of x has 3 real roots if a lies between the range minus 4 to 4. Hence the correct options are B and D. So the answer over here is B and D. Now for further visualization, let's go to the graph and see another beautiful animation. I hope that you can see the graph. This over here, this blue graph, represents our initial function, that was x to the power 5 minus 5x. Now let's make it the dotted line. Now if I take this red function, denotes the x to the power 5 minus 5x plus a, where a is taken as the parameter. Let's see what happens when a varies from the range minus 4 to 4. You can see that how the graph moves upward and downward as it varies from a. Taken in a more detailed manner, when a reaches the value of minus 4, you can see that the graph cuts exactly at this point and in this point. And similarly, when the graph reaches exactly at the value at the point where a equals to 4, you can see that here it cuts at one point and here it cuts at the another point. And similarly, you can see this beautiful animation that is shown over here, how the value of a influences the value of x to the power 5 minus 5x plus a. I hope that you have understood this problem and enjoyed the video. If you did, please give it a thumbs up. Please subscribe to my channel. Feel free to suggest any other alternative solution in the comment section. See you in the next video.